Good day to you, teacher. My name is Huỳnh Chí Nguyen, and my student ID is 22151032. And today I would like to uh, pre um, present my project on designing an SCADA system to control a chemical tank. Firstly, I would like to introduce my factory I/O scenes. As we can see here, this one is a very basic model of a tank, which can be taken right away from the models that the developer already given to us. Here we have a fuel valve. This one here is used to pump chemical fluid, or in this scenario we can call it water for short. This one here is a level meter in order to measure the level of the water inside this tank. From here we have a discharge valve in order to pump the water inside this tank out of the tank. And here is a flow meter which is used to measure how fast we are pumping the water out of the tank. Here is the control box. It's pretty basic. It includes the start button, the stop button. This potential meter serves as the tools to set the desired water level that we want. Here we have two displays. The first one, it will display the water level that we desired, that we set. The second one is to display the real water level that the flow meter here measure it. And the next potential meter is to set how fast we want the pump the water out of the tank. And the third display here is to show how fast the water is being pumped out of the tank. That's everything I want to say about the factory I/O scenes. Next, I would like to introduce my TR program. First one here is the devices and network that I use. For a network, I use the ProfileNet network from CMS. For devices, I have three main devices. The first one here serves as the control station of the network. The second one right here serves as the field station of the network. And the third device here is the VFD, the device that is used to control the motor. Secondly, I would like to talk about the main program. In the network one, we have this box, which is to call down the original functions that was made by the developer to run the PLC. The model that I use here is the S7 and 1500. For network number 2, I use it to scale the height of the water inside from 0 to 100 centimeters. I have to scale it because the the initial value that we measure from the level meter. It is from a real, the type of that data is real. And from here, from the box norm to box scale, we will set it from min 0 to max 100 stands for this range. This range right here is the maximum range of maximum value range of the sensor. And after that, we will get this tag here. And from this tag here, we need to convert it from real to integer right here in order to display it. Next one is the same scaling format, but this one is used to scale the set point. This one here to scale the analog VFD signal, because as we all know, the output will be the output from the PLC will be digital, and to scale it to VFD, it will turn back into analog. Here is the start-stop system program for the buttons. Here is the setting for the discharge valve. And finally is to convert to HZ, which is to show how fast the discharge valve here is working. This right here is the PID block because the control method that I use is PID. Now let's run the program. For the driver here, on address here are compatible with the address for this text that was programmed in the Portal. For configuration, make sure to use the correct model that I chose. This symbol indicates we have connection. And now I will open the where is it? The HMI here. PC system HMI screen. This is the screen that I designed. Here's my name, my student ID. We click to start the simulation. Yeah, when I give it a set point, for example, graph 40, we can see that this value here is being sent to display in the HMI. We press start, and the water is being pumped in. Alright. When it nearly reach the water, the set water level, it will begin slow down. Now we discharge it, make it a little bit faster. So now we can see that because the water level inside is lower, so it starts to pump into again. This is the water flow, and this is the speed of the motor of the pump. And that's the end of the simulation. And for the VFD, we have it right here. This is the process value scaling. No. Yes, this one right here to scale the output value from the PLC, and then we have to scale it again in order to get the real output signal in order to run the motors, which is the water pump. And that is the end of my presentation. Thank you for your watching.